Okay, hopefully you did part H on your own from the last video, but here we go. 3 times 4, that's 12. We know that first term is going to give us an x squared. The outsides give me a 3, and the insides give me a 20, and we know those are going to add up because they're the same sign, so we have a positive 23, and we know those are x's. And my last 5 times 1, which gives me a 5. Notice that these two things were the same sign, and we got a positive here, and those two products, outside, inside, added up, and they kept the common sign there. And so that's our product. All right, now the next one, what we're going to notice with this next example 6 is we don't have two binomials of the same form. And when that happens, we will not get a trinomial because the outsides and the inside products aren't going to be like terms. So let's multiply out example 6. So we're going to do our first times our first. And x squared times x is going to give us an x cubed, and then we're going to do our outsides, x squared times a negative y, so a negative x squared y, and then we're going to do our insides, y times x, so that's going to give us a plus xy, and then our last terms are going to be y times negative y, that's going to be a negative, and that's a y squared. And so what you see is we have 4 terms here that are not alike whatsoever, and therefore they're not going to combine down so that we get a trinomial. So that's what happens when we don't have binomials of the same form. So if we don't have an x with an x in the first here and a constant, or even with a y and a y, it would still be the same. So moving on to our next problems, we're going to be seeing that we have a pattern that establishes itself from what we were seeing before when we were multiplying binomials, where we had the leading coefficients up here, the x's, just an x, and we had a constant here. When we did that, what we saw is that the numbers that were here and here added to give us the middle term and gave us a product that were our last term. Well, when our constants are 1 and we have numeric coefficients on the x, we're going to see a very similar thing happen, except for the numeric coefficient of the x squared is going to be that product. So what I'm saying is that 5 times 3 is going to be our product here, giving us the x squared, and then 5 plus 3 giving us the 8 is going to be our middle term, and then the last term, 1 times 1 is 1. So we're doing the same shortcut that we did before, it's just that the constant is not our product, it's the numeric coefficient of our x squared. So let's go ahead and FOIL this out to show you the same thing. 5 times 3 is 15, x times x is x squared. And then my 5 times my 1 gives me my 5x. And then we have 1 times 3x, which gives me 3x. And then we have 1 times 1, which gives me 1. And what we see here is 15x squared, and then plus 8x, because the 3x and the 5x are the same, and so they add, and then we have plus 1. And you see that's the exact same thing that I got there. Now let's go ahead and try part B with the shortcut, right? The 12 times 3 gives me my numeric coefficient of the x squared, and we have both of these being negative signs, so my middle term is going to be negative. Remember, we recognize that. That's the only tricky thing when we do these that we have to be careful of. So we have 4 plus 3, but it's going to be a negative 4 plus a negative 3. And a negative times a negative does give us a positive, so this one is a positive. And that's where noticing that this is positive when we have the same signs, and the middle sign is always going to be whatever those signs are. That comes into play here as well. Now here we have just a tad bit more trickiness, because when we have one of each sign, the larger product is the sign in the middle. So we have 5 times 6, which is 30x squared, and then we have a 6 minus 5, which is 1x, and then our last one is a negative 1, but we have to be careful on the sign. The insides are going to give us the negative 6, and the outsides give us a positive 5, and so it actually is a negative 1 in here.